Hello, so David here again. I'm gonna just go over the Go code now that I've written regarding the debug with me set of videos. And again, so that you can be certain that it's me, though it's not the best proof in the world. But I just want to also reference. I use this as a mechanism to outline the uh, necessity and the context switching related to this overall process. But regardless, that's beyond the point, right? So the in the context switching, I mean that like the amount of thought and process I have to put into things, and I know that this is also a bit derogatory. That's beyond the point. There's questions and doubts about that, but we confront things as we encounter them, right? In general, and I think that's the way that works. So I'm here now, right? Um, just sort of gonna go over the Go code, and I notice that these videos can be really long. The best way to do it is to not have to edit anything, or just like go straight through the process. I'm just gonna just bring this down here to, oh no, hold on, I put the wrong, right? So this here, cool. Right, so I'm gonna put this about here, and then what we're gonna do also, we're just gonna go over the can I F11 acquire yeah, and then what we're gonna do, just gonna do make deploy all, as mentioned previously. That should deploy everything as intended, and hopefully let's see here, you just gotta do that storage rm. Cool. And then just gonna rm, nope, not that. We're gonna rm docker git and rm kubernetes git, right? I could put those in the make file, but I can't be bothered right now. So this is what we're gonna start off with doing. So this is gonna just provision everything as intended, and I think that the make file orchestration is very key in understanding most things, as mentioned previously. But and because I'm having issues with some of the environmental concerns within the Google environment, sometimes it just breaks in weird, unexpected ways. So what I'm gonna do, I'm gonna leave this open here at the side and just monitor that, because what I have to do, I actually have to go when the build process starts, because I'm having issues actually monitoring the containers. I'll show you that in a bit, when the Docker containers start to build, where I'm having the issues actually checking to see if the container has finished building, and that can obviously be resolved by checking whether the build, the Docker build, is actually finished, and we can solve that by actually just having the gcloud command monitor the cloud build and detect the particular Docker build using tags and labels and things of that nature, which would be ultimately pretty cool. So I've got a little bug in my brain that's just like okay, do we, yeah, I don't think that, okay, the zip files thing is so cool. So just gonna look at the golang file here, and yeah, and there's a bunch of issues that I'm seeing, which hopefully I'll be able to show you there, but let's just go over this really quickly. So we've got a couple of things that we import here that are of relevance: the Kubernetes APIs and the functions framework for Golang. And then we have a bunch of variables here. We have basically this takes a string of bytes, or an array of bytes, if you want to call it that. We have errors, which is a type. obviously, and string and ball, string, and a couple booleans, right? That's the point. The cloud init function registers this for us to be able to use in our entry point. And we have a couple of structs here that are important. For this struct here is for handling JSON data, and then we can marshal and unmarshal that data. And the message is, and this other structure is for handling a pub sub message, which is pretty cool. And we have this here for health checks when running on containers, because again, you can run this in Kubernetes if you want to, which will probably be more sustainable than Cloud Run and Cloud Functions if you have like a large cluster. And you can also use this as an operator type of thing in one scenario or another. In one scenario or another. So here we just create a go function. So we create a thread, a go thread that runs this function here. So that basically takes this function, and whenever this is called by a process, it basically runs this handler here, which is just like a function, and then that function basically takes a HTTP response writer and a reader, and what we do is we just take this and we send back to the writer 200 okay. Is it read or request? Okay, I believe that might be the request itself, which you can then extrapolate for further information if we need to. And then here we have the HTTP listen and serve. So basically this means that it's running on port 8080, and then that causes a nil there. Basically this is just a go thread, so this will spawn a go thread. Okay, so once you spawn the go thread there, we can then handle messages. So this is the pub sub trigger, which when we register the function, we specify it as the function to be exposed to cloud to cloud functions, and then we have an event here. We take the event. Let me just jump to handle message if I can find that. Okay, so handle message, as you can see here, simply what it does is it takes the message, it takes the event, and then with the event we check it for errors. If there is no error, we then or if there's an error, we return the error. If there isn't an error, we unmarshal the data. And then once that data is unmarshaled, or at least we just take the data from the message section, because here we take the pointer, the data as actually takes out the information from that particular or at least converts that into a type of structure that we can actually extract information from. So we can look, it converts that into a structure that we can actually okay, so it takes that information and then it puts it in this data structure here, so this struct, and then just returns that. But if you remember here, we defined the message published data, basically that's a pointer there. So this pub even, which will be the event, will basically put information in that pointer, and then we can access the information as needed there. So if we just look here, this is the message is a pub sub message, so that's another structure elsewhere, and the pub sub message has data here. So yeah, so pretty much that's just pretty much how that's referenced there. And then that handles the pub sub message. We put that in event message, and then once we put that in event message, Once we put that in event message, we're then able to, I'm really having pretty weird issues at the moment. So I'm hoping that this will get detected as intended. Okay, cool. So here we have switch event message, which again I've mentioned before, the switch statement. So we will take the message, and whatever is in the message, it will basically run that particular function. And for our key, and if it's default, if there is no, if that doesn't, if that message hasn't been configured to be received, then what it's going to do here, it's going to do an os.exit, right? Cool. So now what we're going to do, we're just going to take a look at the run service. So run service is the main function that handles a lot of what we need to do. As described prior, basically it spawns a Kubernetes client by running get kube client. Then it waits until the pod is ready. We'll look at that function in a bit. And then if the pod is ready, it returns error or the IP address. Basically what it does is it takes the Kubernetes client, it takes the namespace, and it takes a label to identify the pod, and it takes whether or not we should get the IP address of the pod, and if we should get a public IP address, or if we should just get a cluster IP address, right? And then once we have that, we're able to then do either error, and you'll be able to tell the reason of the error based on if the pod is running, or if it's another particular issue, and any other information required there. And likewise, the Grafana service does the same thing pretty much. It generates for us a Grafana pod IP address. But as you can see, with the Grafana pod IP address, we actually want to get the public IP address, because the pod is actually not running in this. If we're running this inside the cluster, we could use the cluster IP, but because this is running in a cloud function, there might be ways of actually connecting cloud function to the cluster IPs, but we're not doing that at this present moment in time, using read tables and interface specific interfaces into the network, etc. That's pretty much it. So right now we're just gonna go ahead and wait for the, actually no, I think it's still fine at the moment. This is just the Docker files that are being pushed. All right, so yeah, so pretty much that's pretty much it. If we're running in the cluster IP, then we'll be able to just to use the cluster IP however we're running it publicly. So, and there's ways to do that with cloud function, but that's not really the key point at this present moment in time. The important thing is, cool. So now we've got that IP address. We can use it to get a Grafana client. Oh, cool. My bad. Okay, yeah. So we're waiting for the pod. Once the pod is there, then we can get a client by then authenticating to the pod, and then we upload dashboards, right? And for that, you know, you can, in the cloud function, go to the cloud function source code, and then there's a JSON file. The JSON file contains the dashboard that we want to import, and we pass in the Prometheus IP address so that we can actually set up the data source for Prometheus, right? So now what we do with the wait until pod function, you can see here it takes the client as a Kubernetes client set. It takes the namespace and the selector string, which is a label to identify the Kubernetes core. So now, what am I need to gear here, and I'm just gonna yeah, like again, it fails in weird ways. Just let me just, come on, it's gonna start in a minute, or at least it should do. Well, it will. beat it to the punch. I gotta cancel it. Cancel. Tiller row is also already created. Okay, cool. At least it didn't thingy because so I'm gonna manually trigger this job later. But as you can see here, I was having these particular issues. Here it was stating that it needs service usage. Why does it service usage services get? I don't understand why it needs that. Those particular permissions there. Service usage Google APIs.com. I don't know why it needs to have that in order to run a simple command. In order to run see if I can find. Okay, cat Kubernetes cloud build. Right, so all it has to do is it had to run this command here: gcloud artifacts docker images describe, and then the location, right? But what we are actually seeing is that it's requesting these extra permissions that aren't needed, right? From my perspective anyway. If you look at IAM here, and then you can use this trigger point here, and you can see the service account here. And if we try add a profile and say service usage, like, why does it need ability to enable, disable, and inspect service states, inspect operations, and consume quota, and why would that be required? Is my ultimate. And then here it's like gcloud artifacts docker images, even though it has artifact registry administrator saying artifacts docker images and docker describe, which is completely dumbfounded from my perspective. I don't really understand why that's the case and why it requires that. So that's why I stopped the build, and I'm just gonna do this part manually until I can probably understand. Like, obviously I can resolve it in one aspect, but not right now, because sometimes it just breaks in ways like that I don't think that it should need that, and it shouldn't need that to perform that particular call. And I don't know the actual role that the service administrator role provides service usage, but I don't see why that would show gcloud artifacts.docker, right? .describe. Why would that be in the service section? And when if we try to just go to IAM again, and then if I try go to just, you can see the service role exists here, but if I try to go roles here and just say service okay, is it gonna show me the no, you see that's not what just service usage admin. Okay, cool, we can see the role here. And if we look at the role, it does not have any docker anything here, so I don't understand. I completely don't understand that particular section. So sometimes you can run into issues like that when using GKE. So I'm just gonna let those containers build for a minute while we look at this wait until pod run ready function. And I think now what we can actually do, we can actually go ahead and exit this. I don't think we're gonna. Okay, yeah, we can exit this for now. Alright, cool. So here we can see it basically does for pod error the cube client, right? The core v1 API. We get the pods, we pass it in the namespace, we ask for a list, and we provide list options, and we specify our label selector here, right? And if there's an error, we get error, etc. And the error is returned as well, right? And then so when the error is returned, that's when it's actually printed here. So we get useful information regarding that. And then we have the length of pod items here. So we get the length of pod items here, and then we just check to see that it's greater than 0. We take the first one because that's the one that we're mainly interested in. And then once we have that, it's basically a data structure that we can use. So a lot of working with Go is you can use the Go. You have to use the Go interface, the docs interface there, because it gives you the data structures. Like I was just in there just looking at exactly what data structures I need to have. And then status, and then phase, and then we check that the pod is running. Pod running is also another data structure. So we check that's what the phase equals, and then if the pod is running, we print we just print a message saying the pod is surely running, and then we state here that the actual return type, we say if IP return equal true, if IP return equal true and public IP equal false, then return true, and the targeted. So if you don't want the public IP, we just take the pod IP, and then we return that, right? Or if we just want to check if the pod is running, just you see here we just return true here, right? So if we just want to check if the pod is running, we just return true. Or else if, right, if we want to get the pod IP address and want to get if we want to get the public IP address, yeah, if return true, and if we want to get the pod IP public IP address, we'll retrieve the public IP address as following. Core, right, so here we say kubectl core v1, we want to get services, so we give the services namespace, and we ask for a list, and then we say from the list we provide the list options, and then we provide our label selector, which is app grafana. Luckily enough, it's app grafana, though this should actually be the variables selector, but at least I know that in this instance that's the only service that we want the public IP address of, right? So that's that. Cool, and then now we return the load balancer IP address. I had to do some funky stuff here. I had to use the reflect package, but I had to look at because it wasn't easy actually finding this load balancer IP address. It will be in status, wouldn't it? But I suspected that it would be in another data structure. It was actually quite interesting because I thought it would be like in the in another data structure, but then it wasn't in another data structure. So that was pretty much that. I had to use this reflect package to inspect where the value might be, because I could see by inspecting the pod spec. Yes, I thought it would be in the spot spec, and then in the services section, then you find the load balancer address. But I think the spot spec actually just gives us, or the spot spec data structure type actually just gives us information related to the spec that was used to create it, whereas the status actually brings us information about the deployed ingress. Although I could see it because because I could look at items, isn't it? Using the reflect package, and iterate through the actual data structure to find which particular value I was looking for. Cool. Right, so that's wait until pod ready. Right, so that's the wait until pod ready function, and then the upload dashboard function is pretty straightforward as well. Similar thing. We pass in the client and the file name and the Prometheus pod IP address, right? So the client should be authenticated. I'll discuss the authentication process later on. So here it's pretty simple. We take that the Prometheus pod IP address, then we create a string, which is this string here with the IP address, replacing this %s sign. Then we create the data source. So this is a data source structure, right? So this is a data source structure in the SDK. So a lot of this is also available on the SDK. And some of the SDK examples there. So it's just piecing those together. And I say that I'm no Golang expert as well. So then we take that data source, we name the data source, we provide the type, we provide the IP address or the URL. Proxy, yeah, we set basic auth here. That's gonna be a false, but we have to use a pointer for whatever. Actually, no, it's admin, but we have to use a pointer to it for some strange reason. Where is it? Trying to see where's that defined. Where is basic auth check? I'm seeing it up here, am I see? Basic auth, no, that's just a boolean that should be false. Okay, no, sorry, that is a boolean. So just saying that there's no need to auth there. Cool, right. So that's pretty much it. And then so once we got the data source, we submit that via the client into create data source. Cool, data source params, status message there. And if there's an error, return a status message else, report that the data source was created successfully. Then we read the file containing our cube file. Let's just double check on this build here again. See if it's Alright, yeah, so the Docker file is finished building the containers there, and then we can just quickly run the deployment. Right, so we're just gonna retry this build here, so then that should deploy the containers. So if we do this deployment here, everything should ultimately right. And then so we take in our dashboard, we unmarshal it. So the board is a JSON file. We take a pointer to that JSON file, then we place it into raw board in some type of format, or unmarshal it into raw board is whatever structure that's required for that to occur. And then we delete a pre-existing dashboard based on the board slug, which will be extracted from that particular data structure. Okay, no, we take raw board and unmarshal it into this data structure here. The update slug is like the update slug is like an interface for that particular typo or structure or whatever, and then basically it says update. Yeah, so basically we take the value, the name of the actual board, and then it's pretty much that. Cool. And then here we set dashboard parameters, and then we set board. So this is where we actually go ahead and import the board, right? And then there's a bunch of different stuff here that has to occur. So here we get cube client. There'll either be a success or an error there when importing the board, right? And this can always be extended and customized in alternative ways. Cool. So here what we got the get client, then we return a Kubernetes client set, which is then passed down to all the other functions where required. And then we basically, it's a simple process. It just load the kube config file and build config from flags or from the file, etc. And then we generate a new config which gives us a client to be able to authenticate, and then we return that. And for the Grafana, we do a similar thing. We have our default admin string here, and we have our client. For our client, we want to specify a few configurations here. So what I was trying to do, I was trying to edit the host header and user agent, but actually there's what I feel is always a bug in the client application. And working with open source code, that's when we can go and fix this, because these values here can't be overridden, right? The user agent and the host can't be overridden, unfortunately. So because I was trying to make it so that I can use the ingress to communicate, but I can't use the ingress because I can't edit the host header, and then I don't want to start looking at editing host files on cloud functions, etc. So I just use the public IP address of the container of the pod, etc. So basically that's pretty much that. And then so this is an interface, right? So we define this data structure, deep mod transport, and we define this function here that takes a http dot round tripper, right? And well, at least it takes that type, right? So what we do is we say that technically we don't have that particular type, so we pass in a nil, and then when we pass in a nil, I found this intuitive solution from a Stack Overflow post from assistance there. So we put a pointer to our transport, right, and the transport should support this HTTP round trip method. So so basically, if I just go back up here, what is this? So basically we define here the data structure, right, with this as the type, round trip as a type. And so when you pass it, so when tr is nil, that means that there isn't that, and the transport is basically of type round tripper. And so we can pass a pointer here, which creates basically this config here, and then when we pass this config to the pointer to the data structure there, which is what will ultimately be returned to our HTTP client. It gets passed through this first, so the request gets passed through this first, which then performs various modifications to it. So we get like a request. So okay, so this generates a request, right? This generates a request, and this generates a request. We pass the request into our data structure interface, right? And when we do that, we have the request, and on the request we modify the header, and then when we modify the header, we basically return the header via the round trip function that we call on this particular data structure that we would have added, that we would have passed down here, which is basically the request. And so when we attach this request here, it should perform those particular modifications on the URL. Though that's a hazy explanation, but it was an iffy thing for me. But I just understand that basically these are interfaces and decorator or modifier functions that help you to actually customize specific aspects of a request. And then what then happens is that a HTTP client is returned here. You can either use a default HTTP client, or you can use this one, which modifies it in weird ways, in interesting ways, or however you may like. So here, these two values, user agent and host, can't be overridden. But if I put in another header, you will see it you can see that in the request. And here we generate a new client by performing that authentication and then returning that client, right? And that's pretty much it. And so you can see get client used here. You can see get queue client used here. You can see wait until pod is ready used here, and here for the Grafana pod. And you can see the Grafana client used here. And you can see here the call to the upload dashboards, and then the function would ultimately exit here. So that's pretty much it. I don't know if there's something here that I'm missing. Was I meant to? Okay, because I did get alright. And that's pretty much it. So I'm gonna upload this to GitHub at some point. Or yeah, and that's pretty much that. Oh no, done LA. All right, cool. Yeah, there's some OL as well can be used there, but LA brings only and LS brings in. All right, cool. And then so that's that there. And so here you can see the deployment worked wonders. I need to get the all right. Ah. Hmm. Okay, there's one minor issue here. Let's see if I can. Okay, if we're lucky. Nah, this is not gonna be the one that we need. Gotta run kubectl. I'm not looking forward to running kubectl on this. Alright, here's what I'm gonna do. I'm just gonna go to because I was meant to take the could I do a Terraform plan maybe? Terraform no, I can't do Terraform plan there. I don't have those vars. Let's see if I try to. Yeah, it's probably gonna ask me to thinking because I'm just thinking how am I gonna get the cube config from this? Terraform outputs. There ain't no Terraform outputs. Oh, cool. Alright. Sometimes it's things I know that I think I don't know. And then I can do nvim kubeconf, and then here I'm just going to delete everything here. Insert and paste. Cool, and then I'm going to just kubectl. Cool, right. So what I'm looking for, I'm actually looking at get pods. Or namespaces, actually I know I'm just looking at the ingress to find when I get ingress. Right, and I need the ingress IP address, which is this, and I just gotta edit my Etsy host file here, just make sure that cool. Hope you didn't see that. If you did, that would be a very wrong thing that I don't know. cool. So that's that. So let's just take a look. The only other thing that could go, because I know that, so now if I say, because I know that if I go grafana.foo.org, we have our grafana instance there, and hopefully the cloud function run as intended, unless Google fudged up in some other ways, something might have. Okay, so we're just gonna take a look at the data sources here. Yeah, so it's that fudged. So we can do also Prometheus. You can see that we have foo.org, and we also have the sock.shop.foo.org. Cool. So this is the, and then this is going to be like some load test running as well somewhere. Yeah, the build yields, at least we had one successful build. Just need a better way of actually checking to see if a container has been built that doesn't require any permissions. Right, so yeah, everything deployed correctly, so there'll be like a load test running. The message was sent. Alright, so now we're gonna look at cloud functions, right? And I know somewhat what might be the issue here. Now I use this window here. So yeah, so cloud functions. Gotta go fucking job center, man. Ah! I hope they're not gonna stress me over these things, man. Like, but yeah, my mess long is still don't know that man going to that, which shouldn't be too ultimately bad, you know. Yeah, man, I had a job. They let me go, man. They didn't want me no more, and I gotta explain that to them. So yes, this is a cloud function interface. I think I've showed this before. You know, you got source variables there, but for the interest of time, let's just look here. We're looking for the, okay. So if a message doesn't get delivered, it stays in the queue. And here it's saying that unknown value, right? So that means that if I look at the source code here, we can see that there's probably just my memory issue. I ain't gonna blame anyone for that. Alright, cool. So service deployed is definitely not the message that we are intending to have here. I had to change it because I was debugging a similar issue that I was having recently, but let's ignore that. I can show you that issue in a moment. So that's what we're seeing here in the logs, but we're also seeing a few other things, right? Because hello, I didn't send that. See, no one sent it. It's just sent ages ago. Oh, but it's probably like the same bucket. It has to be the same. Alright, so now what we're gonna do, we're just gonna do gcloud pub/sub message. We're gonna send hello. Right? We're gonna see that the hello message is gonna arrive. We're gonna get world hello. Is that correct? Oh no, we're not getting bored hello. Oh, there, world hello, right? So that run okay. We had no issues there. But then if I try to do service deployed, svc deployed pl svc deployed, right? And I see we're gonna run into an issue here somewhere, right? Unfortunately, I understand that this is the error that we get, because after this point, the message is just gonna be stuck in the pub sub queue, and we're just gonna keep seeing it. Invalid memory address, and you'll point at the reference. I don't know what that means. And you know, and it's in the Google Cloud Function framework. So you see, so that's the ultimate issue we're having there. Yeah, and if I just to verify, if I send that again, service deployed, right? Which is ultimately what the function is looking for. Give it a minute. See there, we just get another panic again. There we go. Right. I'm not too sure as to why that is. So yeah, so I don't really understand. So as you can see, the data source wasn't actually provisioned. So that didn't actually work out as intended. So ultimately, we either have to just leave it be, or we can do the following. Alright, so like I said before, refactors and things of that nature. That's the Go function we have, but it's not working as intended. So what I'm gonna do, I'm just gonna so I have a similar so I have that function here because I was working, or at least the one on my local system, right? The function on my local system. So here I can just run this, I believe, as long as I believe it's pointing to the right config, it should be pointing to the right config file. Yeah, man. Oh shit. I think no, it's not. That's bread. Yeah, nah, I must have forgot a little bit of a pain de chocolate on the thing there, but it doesn't really matter. Damn, man. Alright, cool. So we're just gonna run this, go run. Cool. So as you can see here, it just does a bunch of things. It says run function success, pod is surely running, it does authentication and uses various information to access the pod there. And then if we just, it's the same function, but excluding the cloud function stuff. It's quite difficult to debug cloud function things sometimes. So now if we refresh, you see we have the data source added, and if we go to manage, you can see we have the Kubernetes pods configured. Here, CPU usage NA. There we go. We have the dashboard configured. We have the front end latency set at queries per second or per minute, I suppose. And we have here front end latency in general, how long the requests take to finish, to some, I'm not even sure how long, per minute, each minute. Yeah, it's on a minute bucket there, and we have on 99 percentile, and they're pretty decent metrics for my conceptual side of things and my understanding of the notion. And yeah, and that's pretty much it really. We can drill down to that to this particular minute here. And yeah, that's pretty much it. And just to show that the function does actually work, the function that I did detail about, but it's just having issues at the moment with the Google platform, whether that's my own issues of misunderstanding or what, I don't really know, and I can't really comment on that at the moment. I can only comment on what's happening right now. Cool. Right, so you see the data source has been deleted and the dashboard has also been deleted. And if you just run this function again, it's going to do the same thing. Once it's completed, we just refresh Grafana and we see the dashboard is there, and we also see our metrics as there are there. We just refine these a little bit closer just to the last hour or so. Yeah, that's pretty much it. CPU usage, memory working set, networking, and a bunch of other stuff there. We've got memory set, we've got CPU set, and then file system usage, and we've got some metrics related to data usage here in regards to cores, file system, and also memory. So the whole cluster overall has about the whole cluster overall is about 23 gigabytes worth of memory, right? And we've only used 6.35. And the CPU usage, we're using 0.73 cores, so there's 12 cores. I think this one here might be a bit off though. I feel like we're using way more than this. And we have used that much space, and there's 200 and there's and there's about 250 gigabytes worth of space there. Just check what metric is used for this. And yeah, that's pretty much it really. I hope you enjoyed that, and yeah, I'm gonna put this up to GitHub. Right, the reason why this might be a bit off is because these functions sometimes they're a bit spaced out, you see. So now if I do that, we should get the correct value. And if I put refresh there, still saying shift enter, shift enter, shift enter, shift enter. Unless this value here determines 0.73 cores as in the total amount. If I go back to okay here, alright. So if I do sum, I don't know what the sum, that has to be what it, because sometimes it does impact that, although it looks like it doesn't right now. It's gonna apply this. Unless if it's the percentage, I'm not too sure. I can understand the metrics as well, but sometimes it's like having that real insight around it. And that's pretty much it really. I hope you enjoyed that, and yeah, I gotta get ready for some other stuff. But you'll find the code on GitHub, and I'll put the repository in the link on the description on this video. So thank you for watching. I hope you enjoyed it. Feel free to comment and subscribe, hopefully.